In the previous videos, we reviewed the probability distribution of a discrete random variable. In this video, we'll consider the probability distribution of a continuous random variable, such as time, weights, measurements, and so on. We'll learn about the standard normal distribution, and we'll develop a skill to find areas or probabilities that correspond to various regions under the graph of a standard normal distribution. We'll also learn how to identify the z-scores that correspond to areas under the density curve. Normal distribution of data occurs often in real world, and the skills that we'll develop in this video become very important as we continue to study non-standard normal distribution further. To illustrate the correspondence between the area and probability, we'll begin with uniform distribution. A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. The graph of a uniform distribution results in a rectangular shape. The important properties of uniform distribution is that the area under the graph of a continuous probability distribution is equal to 1. There is correspondence between area and probability, and the probabilities can be found by identifying the corresponding areas in the graph using the formula for area of rectangle, height times width. For example, during certain time periods at JFK Airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minutes and 5 minutes. Part 1. Find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. First, let's make a graph of this uniform distribution. We know that the times are distributed evenly between 0 to 5 minutes, so our x-axis will be the waiting time. Vertical scale will show the probability. The graph of any continuous probability distribution is called a density curve. And because the density curve of a uniform distribution is a horizontal straight line, we can use this property to find a correlation between the length, the width, and the area. Let me show you how we find this number. Area is equal length times width. The length in this case is equal to 5. Area is equal to 1. To find width, divide both sides by 5. Width is equal 1/5. Or 0.2. Now let's answer the question and find the probability of a randomly selected passenger waiting time to be at least 2 minutes. At least 2 minutes mean 2 or 3 or 4 or 5. So the rectangle that we will consider for the calculations will have a length of 1, 2, 3 and width that is equal 0.2. Area or probability is equal 3 times 0.2 is equal to 0.6. The probability that a randomly selected passenger has a waiting time of at least 2 minutes is 60%, or 0.6. In the next question, we need to find the probability that a randomly selected passenger has a waiting time between 2.3 to 4.5 minutes. We'll use the same graph to help us visualize what would be approximate probability for a waiting time between 2.3 to 4.5 minutes. 2.3 will be approximately somewhere here, 4.5. So the rectangle that we'll look at, approximately, I would say 40% out of the whole big rectangle. That's just my approximation. Now let's find the actual value. The length in this case would be the difference between 4.5 and 2.3, 2.2 minutes, and the width is still 0.2. So to find the area or probability, we multiply 0.2 times 2.2 equal to 0.44 or 44%. We were pretty close to estimated probability. Now let's look at the properties of a standard normal distribution. Standard normal distribution has a more complicated bell shape, so it's more difficult to find the areas, but the basic principle is the same. The total area under the density curve is equal to 1. Standard normal distribution has a mean that is equal to 0 and a standard deviation that is equal to 1. It is not easy to calculate the area or probability of the standard normal distribution because of its shape, so we will use the technology or table A2. We'll use the following notation. P of z less than a denotes the probability that the z-score is less than a. P of z greater than a denotes the probability that the z-score is greater than a. And P of a less z less b denotes the probability that the z-score is between the numbers a and b. Let's read the following example. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with the mean of 0 and standard deviation of 1. So these test results meet the requirements of a standard normal distribution. If a randomly selected adult undergoes a bone density test, find the probability that this person has a bone density test score less than 1.27. I will show you how to find the probability of a standard normal distribution using table A2 and StatCrunch. And in the next video, I will also show you how to use TI graphing calculator to calculate the probability of a standard normal distribution. Let's first draw a graph to help us visualize what we're looking for. Remember, the graph of a standard normal distribution is a bell-shaped distribution with the mean equal 0 and standard deviation equal 1. We're looking for the probability that the person has a bone density test score less than 1.27. Z-score of 1.27 is located somewhere here. We will be looking for probability of z-score that is less than 1.27. So it's located on the left from the z-score. Let's look at table A2 first. Keep in mind that probabilities that are located in the middle of the table indicate the probabilities to the left of the z-score. For example, we need to find the probability of z-score less than 1.27. 1.27 will be positive z-score, so we will look at the part that says positive z-scores. And the graph in the table will show us that the probabilities will be on the left of the z-score. The probabilities are located in the middle of the table. On the left side, you will find a z-score to 1 decimal, and then we need to go to the top of the table and find the second decimal. We're looking for P of z less than 1.27. Go to the right and then go down when you get to 0.07. 7 is your second decimal. It meets at 0.8980. Let's go back to our example and write down this number. 0.8980. So we can say that the probability that a randomly selected adult who undergoes a bone density test has 89.8% chance to have a z-score that is less than 1.27. Now let's do the same calculations using StatCrunch. We need to find the probability of z-score less than 1.27. Go to Stat, Calculators, Normal. We will be dealing with normal distribution. And remember, standard normal distribution has a mean of 0, standard deviation 1, P of x less or equal 1.27. Compute. The probability is 0.8980 rounded to 4 decimals. Now let's do the next part. Using the same bone density test, find the probability that a randomly selected person has a result above negative 1.0, which is considered to be in the normal range of bone density readings. Let's first draw a diagram of what we're looking for. Here's our standard normal distribution with the mean of 0, standard deviation 1. Z-score of negative 1.0 is located right here, Z negative 1.0. And we are looking for probability greater than negative 1.0. Greater is located to the right of negative 1.0, So this will be the probability or the area that we will be looking for. P of z greater than negative 1.00. We will now be looking at negative z-scores part because we need to find P of z greater than negative 1.0. Z negative 1.00 is located to the left of the mean. Remember, the probabilities are shown on the left of the z-score, not on the right. Our probability is on the right of the z-score. So first, we locate P of z less than negative 1.00. The first two numbers of the z-scores are located on the left of the table, and the second decimal is located on the top of the table. Probability of z-score less than negative 1.0 is 0.1587. This is the part that we just found. Now we need to subtract it from 1 minus P of z less than negative 1.00 to find probability to the right of the z-score. 1 minus 0.1587 is equal 0.8413. Now let's calculate it using StatCrunch. We need to change P of x greater than negative 1.00, compute, and you can see the shaded area is to the right of the z-score. The probability is equal 0.8413 rounded to 4 decimals. Now let's answer the third part of this question. A bone density reading between negative 1.0 and negative 2.5 indicates the subject has osteopenia, which is some bone loss. Find the probability that the randomly selected subject has a reading between negative 1.0 and negative 2.5. We'll start with drawing a graph of a standard normal distribution with the mean of 0, standard deviation equals 1, bell-shaped distribution. The z-score of negative 1.0 will be to the left and negative 2.5 will be 2.5 steps to the left. So we're looking for probability located in between these two z-scores. Let me first show you how to find the probability that is located between two z-scores using the table A2. When we use table A2, remember in that table, the probabilities are shown to the left of the z-score. So we'll need to find the probability that is located to the left of negative 1.0, probability to the left of negative 2.5, and then we will subtract to find the difference between these two probabilities, not between the z-scores, between the two probabilities. So let's first find the probability of z negative 1.0. Negative 1.0 is on the left of the table, and the second decimal is also 0. So P of z less than negative 1.0 is equal 0.1587. And now let's find the probability for the z-score less than negative 2.5. Negative 2.5, the second digit is also 0, is equal 0.0062. Now we'll need to subtract 0.1587 minus 0.0062, which is equal to 1525. Let's go back to our drawing and transfer the numbers from the table to the drawing. 0.1587, 0.0062. So this difference is equal to 0.1525. Translating it to the human language, we can say that there is 15.25% chance that a randomly selected subject has a reading between negative 1.0 to negative 2.5. Now let's look at how to find the probability between the two z-scores using StatCrunch. StatCrunch makes this process extremely easy, and you will see it. Click Stat, Calculators, go down to Normal, select Between, and change the numbers. Remember to put the smallest number on the left of x, negative 2.5, and the larger number on the right, negative 1.0. Click Compute. The graph depicts the probability that is located between negative 2.5 to negative 1 z-scores. Translating, 15.25% of people who undergo bone density test have z-scores between -2.5 and -1. In the next video, we'll learn how to find z-scores from known areas. Stay tuned, subscribe for the updates.